Right at this very second, an invisible ocean of ancient light is passing directly through your body without you feeling a single thing. This light did not come from the sun, and it did not come from any star in our night sky. It was born long before a single star existed, during the violent, fiery birth of the cosmos itself. Every time you take a breath, thousands of these ancient light particles travel straight through your room. If you love exploring the deepest secrets of our universe with real science and no fake hype, hit the subscribe button right now. Joining our community means you will never miss a journey into the strange realities of space. We break down the biggest cosmic discoveries in simple words so you can always stay one step ahead. To understand where this mysterious light comes from, we have to travel back in time to the very beginning of everything. Most people look up at the night sky and see a dark, empty blanket dotted with bright, twinkling stars. It looks calm and quiet, as if space has always been this exact same way forever. But modern science tells us a completely different story about how our universe started. About 13.8 billion years ago, everything in existence was squished into a space smaller than a tiny grain of sand. There were no planets, no moons, no galaxies, and no empty room between things. Then, in an instant, space began to expand at an unimaginable speed during an event we call the Big Bang. It was not an explosion in space, but rather the rapid stretching of space itself. In those first few moments, the universe was blisteringly hot and incredibly crowded. It was filled with a dense, glowing soup of subatomic particles called a plasma. Because everything was packed so tightly together, light could not travel anywhere. Every time a tiny particle of light tried to move, it instantly slammed into a charged particle and bounced back. Imagine trying to shine a flashlight inside a room filled with super thick fog or smoke. The light gets scattered instantly in every direction and cannot break through. That was the state of our universe for its first 380,000 years. It was completely opaque, holding light captive in a dense, glowing cloud. During this early era, the universe was an energetic furnace expanding at staggering speeds. Matter and radiation were locked together in a chaotic thermal dance. Every electron was constantly deflecting photons of light, trapping energy in a perpetual cosmic gridlock. Nothing could move long distances without being knocked off course. Because of this constant scattering, if you had been standing inside the universe back then, you would have seen bright white light in every direction, but you could not have seen any objects. Everything was a thick, blinding blur of extreme heat and energy. It was a universe with plenty of light, but no vision. Then, something remarkable happened as the expanding universe continued to grow larger and cooler. The temperature finally dropped down to about 3,000 degrees Celsius, which is roughly 5,500 degrees Fahrenheit. At this specific temperature, positive and negative particles were finally able to slow down and join together to form the very first simple hydrogen and helium atoms. The moment those first stable atoms formed, the thick fog suddenly cleared away. The charged particles that had been trapping the light were now locked safely inside neutral atoms. Suddenly, space became transparent, and all the trapped light was freed at the exact same moment across the entire universe. This sudden release of energy created a massive flash of heat and light that shot out in every direction. It was the first time light was ever allowed to travel freely through space. Scientists call this historic event recombination, because particles combined together for the very first time. That single moment produced the oldest light in existence. Once this light was set free, it began a journey that has lasted for over 13 billion years. As space continued to stretch out in every direction, the wavelengths of this light were pulled longer and longer. What started as intense, blazing heat slowly stretched into cooler radiation, spreading across every cubic inch of expanding space. Did you know that the light from the birth of the universe is still moving through space today? If this incredible cosmic fact blows your mind, take a second to hit the like button right below the video. It tells the algorithm to share this deep science story with other curious minds, and drop a comment below letting us know if you have ever heard of this ancient light before. For a long time, human beings had no idea this first light even existed. In fact, for centuries, the smartest scientists on Earth believed the universe was static, meaning it had no beginning and would have no end. They thought space was infinite, unchanging, and eternally quiet. Albert Einstein himself originally believed the universe was standing still when he wrote his general theory of relativity in 1915. He was so convinced that the universe never changed shape that he actually added a fake number into his math equations to keep space still. He later called this addition the biggest mistake of his entire life. In those days, even the world's top astronomers thought our Milky Way was the entire universe. They assumed that beyond our galaxy lay endless empty dark void, unchanging and timeless. The idea that space itself could expand or have a birth date seemed like wild science fiction. That old idea began to crumble in 1929 when an American astronomer named Edwin Hubble made a shocking discovery at the Mount Wilson Observatory in California. He was using a massive telescope to measure how fast distant galaxies were moving away from Earth. He expected to see some galaxies moving toward us and some moving away in a totally random pattern. Instead, Edwin Hubble discovered that almost every distant galaxy was speeding away from us. Even more surprising, the farther away a galaxy was, the faster it was moving. This proved that space was not static at all, but was actively stretching out like a gigantic expanding balloon. This discovery sent shockwaves through the global scientific community. If galaxies were rushing apart from each other today, it meant that yesterday they were closer together. If you trace this cosmic motion backward through time, there had to be a moment when all matter in the universe was touching at a single starting point. If the universe is expanding today, then that means if you rewound time like a movie, everything must have been closer together in the past. If you rewind time far enough, the entire universe must have started at one single point. This realization gave birth to the Big Bang Theory, but many scientists still refuse to believe it. Critics demanded extraordinary physical proof before they would accept that the universe had a sudden beginning. They argued that expanding space might just be a local phenomenon or a mathematical trick. For decades, two opposing groups of scientists argued fiercely over whether the cosmos was permanent or born in a flash. Theorists like George Gamow, Ralph Alpher, and Robert Herman predicted in 1948 that if a massive fiery explosion really happened, there should still be a leftover heat glow fading across space today. They realized that the intense heat of creation could not simply vanish into nothingness. They calculated that this leftover radiation should still exist as a faint, cold whisper spread evenly across the entire sky. But technology in the 1940s was not advanced enough to pick up such an extraordinarily weak signal. Without experimental proof, the idea sat quietly on paper for almost 2 decades while skeptics scoffed at it. Many prominent astronomers mocked the concept of a cosmic birth, preferring the steady-state theory, which claimed new matter was constantly created as space expanded to keep everything looking identical forever. The debate raged on without resolution because neither side had clear physical evidence to settle the score. That all changed in 1964 due to a complete accident at a research center in New Jersey. 2 radio astronomers named Arno Penzias and Robert Wilson were working for Bell Laboratories in a town called Holmdel. They were using a giant horn-shaped antenna that was 20 feet long to study faint radio signals from space. They wanted to bounce signals off early communication satellites, which required an extremely quiet receiver. To get clear readings, they had to eliminate every single source of radio noise that could mess up their equipment. They aimed their massive antenna at regions of the sky where there were no known stars or radio sources. They expected to hear total silence from the cold, empty depths of space. But no matter where they pointed their antenna, they heard an annoying, continuous background hiss. It was a low static buzz that never stopped, day or night, summer or winter. At first, they assumed the interference was caused by local human activity. They checked to see if radar systems from nearby military bases were interfering with their receiver, but the signal remained steady regardless of radar activity. They looked for commercial radio broadcasts, but the noise did not match any known station frequencies. Have you ever wondered what it would be like to stumble upon a major scientific discovery by total accident? Leave a quick comment down below with your thoughts on how science often happens when people least expect it. While you are down there, subscribe to the channel so you can keep exploring these mind-bending scientific breakthroughs with us every single week. Arno Penzias and Robert Wilson double-checked all their electrical cables, rebuilt sensitive parts, and tested every circuit for defects. They thought radio waves from nearby New York City might be reflecting off the metal dish, but pointing it away from cities changed nothing. They even climbed inside the giant horn antenna to scrape off a thick layer of white material left behind by a pair of pigeons nesting inside. They thought the bird droppings were causing the electrical interference, so they carefully cleaned the entire dish and relocated the birds. But when they turned the equipment back on, the persistent background noise was still there, buzzing at the exact same volume. The noise was completely uniform in every single direction they looked. It did not come from the sun, it did not come from the Milky Way galaxy, and it did not come from human technology on Earth. It was coming equally from every single corner of the sky at all times. For nearly a year, Penzias and Wilson were completely baffled by this mysterious noise. They had spent hundreds of hours troubleshooting their machinery, but the universe refused to be quiet. They were radio engineers trying to do precise astronomy, totally unaware that theoretical physicists nearby were searching for this exact signal. Unbeknownst to Penzias and Wilson, a team of theoretical physicists just 30 miles away at Princeton University was actively trying to build an instrument to look for the leftover heat of the Big Bang. The Princeton team, led by scientist Robert Dicke along with Jim Peebles and David Wilkinson, realized that the ancient heat from the early universe would have stretched out over billions of years as space expanded. When light travels through expanding space, its waves get stretched out like a slinky being pulled apart. Over 13 billion years, intense visible light would stretch so far that it would turn into invisible microwaves. Robert Dicke calculated that this faint radiation should coat the entire sky evenly at a temperature just a few degrees above absolute zero. When Arno Penzias called Princeton to ask for help solving his stubborn antenna noise, the scientist instantly connected the dots. Robert Dicke famously turned to his colleagues in the room and said that they had been scooped. The annoying bird-dropping noise in Holmdel was actually the leftover echo of the universe being born. The Princeton researchers explained to Penzias and Wilson that their antenna had accidentally detected the very first photons ever released into space. The static noise was not a flaw in their equipment. It was the physical proof that the universe had a definitive beginning billions of years ago. This glowing heat signal was officially named the Cosmic Microwave Background, or CMB for short. It provided undeniable proof that our universe was once an unimaginably hot, dense fireball that cooled over time. For their accidental discovery of this ancient cosmic light, Arno Penzias and Robert Wilson were awarded the Nobel Prize in Physics in 1978. What makes this discovery so incredible is what the numbers actually reveal about the scale of our universe. When the first light escaped 380,000 years after the Big Bang, its temperature was roughly 3,000 Kelvin. But because space has stretched over 1,100 times bigger since that moment, that light has been stretched into much longer, cooler wavelengths. Today, that ancient thermal glow has cooled down to just 2.73 Kelvin above absolute zero. That is minus 270.4 degrees Celsius, or minus 454 degrees Fahrenheit. It is barely warmer than the absolute coldest temperature physically possible in nature. This means that outer space is not completely absolute zero, but is warmed by a faint blanket of heat left over from creation. No matter how far you travel into deep space, far away from any star or galaxy, you can never escape this subtle background warmth. The entire universe is resting inside this ancient thermal bath. What if I told you that you have almost certainly seen and heard this ancient cosmic light with your own eyes and ears? If that sounds surprising, drop a like on the video right now and tell us in the comments if you remember old box televisions. Subscribing to the channel helps us make more content showing how the deepest secrets of space touch our everyday lives. Before digital cable and flat screens existed, older television sets picked up signals through metal antennas over the airwaves. When you tuned a television to an empty channel between stations, the screen would display a flashing grid of black and white static, accompanied by a harsh buzzing noise. While most of that static came from local interference and atmospheric noise, about 1% of those flickering dots were caused by cosmic microwaves hitting your antenna. That means when you watched television static as a kid, you were watching actual light particles that began their journey 13.8 billion years ago, long before Earth existed. Think about how remarkable that truly is for a moment. Ordinary living room appliances designed for entertainment were actively receiving ancient signals from the dawn of time. The energy hitting those antennas was generated long before the sun ignited, or gas clouds condensed into the first solar systems. For almost 30 years after its discovery, scientists could only measure this cosmic light as a perfectly smooth, uniform glow. Everywhere they pointed ground telescopes, the temperature read as exactly 2.73 Kelvin down to several decimal places. But this perfection created a massive new puzzle that threatened to break physics. If the early universe was completely smooth and uniform, then matter should have stayed spread out perfectly everywhere forever. Gravity would have pulled equally in all directions, meaning atoms could never gather together to form stars, galaxies, or planets. For our world to exist today, there had to be tiny temperature differences in that original light. Scientists predicted that there must be microscopic ripples in the cosmic microwave background, areas that were just a tiny fraction of a degree hotter or colder than average. The hotter spots represented areas where matter was slightly denser, giving gravity a tiny foothold to pull gas together over billions of years to build the very first galaxies. Without these density differences, the universe today would be nothing more than a giant, boring cloud of cold hydrogen gas floating in total darkness. There would be no solar systems, no rocky planets, and no living creatures to look up at the stars. Finding these microscopic ripples became the most important quest in modern cosmology. Ground-based telescopes tried for decades to find these tiny temperature differences, but Earth's atmosphere blocked and distorted the faint microwave signals. Water vapor in our air absorbs microwave radiation, making precise measurements from the ground nearly impossible. Researchers realized they had to leave the atmosphere behind entirely. To hunt for these microscopic ripples, NASA launched a specialized satellite called COBE, which stands for the Cosmic Background Explorer, in November of 1989. COBE was lifted high above Earth's thick atmosphere so it could measure the cosmic background light without any air molecules blocking its view. The satellite carried instruments of unprecedented precision, kept at ultra-cold temperatures so its own heat would not mess up the delicate readings. For months, it orbited Earth, collecting microwave data from every single coordinate in the night sky. The data sent back by COBE in 1992 shocked the entire scientific community. The instrument detected tiny temperature variations across the sky that differed by only 1 part in 100,000. These fluctuations were so subtle that the temperature differences were less than 30 millionths of a single degree. When scientists plotted these numbers onto a map, they saw a beautiful tapestry of blue and red splotches covering the entire sky. Blue regions represented areas that were slightly colder and denser, while red regions were slightly warmer and less dense. These were the fundamental cosmic seeds from which everything we see today grew. The lead scientist on the project, George Smoot, described the satellite image as seeing the face of God, or looking at the baby picture of our universe. It showed that the seeds of every single galaxy cluster in existence today were already planted when the universe was less than 1% of its current age. For this massive discovery, George Smoot and John Mather won the Nobel Prize in Physics in 2006. Are you amazed that scientists can map the universe when it was just a baby? If these incredible satellite discoveries fascinate you, click that subscribe button right now to follow along with every new episode. Comment below with your favorite space satellite, whether it is COBE, Hubble, or the James Webb Space Telescope. As technology improved in the 21st century, space agencies built even more powerful satellites to map this cosmic background light with incredible precision. NASA launched the Wilkinson Microwave Anisotropy Probe, or WMAP, in 2001, followed by the European Space Agency's Planck satellite in 2009. The Planck satellite was equipped with detectors cooled to within a fraction of a degree above absolute zero, making it one of the most sensitive scientific instruments ever sent into space. Over 4 years, Planck mapped the entire sky with stunning resolution, giving us the clearest picture of the early universe ever created. Where COBE saw blurry shapes, Planck revealed sharp, detailed features in the cosmic microwave background. It was like upgrading from an old fuzzy television to a modern high-definition monitor. Astronomers could now analyze the exact size, shape, and distribution of every temperature ripple across space. When scientists analyzed the high-resolution map from Planck, they were able to calculate the precise recipe of our universe. The map revealed that ordinary matter, which makes up everything we can see including stars, dust, planets, and human bodies, accounts for only 4.9% of the total content of the universe. Dark matter, an invisible substance that pulls on things with gravity but emits no light, makes up 26.8% of the cosmos. The remaining 68.3% is made of dark energy, a mysterious anti-gravity force that is actively forcing the expansion of space to speed up faster every day. Think about what those numbers actually mean for a moment. Over 95% of our entire universe is made of mysterious dark components that we cannot see or touch directly. The cosmic microwave background is our primary flashlight for detecting how these hidden components shaped the history of space over billions of years. Ordinary matter is just a tiny sprinkle of dust resting on top of a massive cosmic structure made of invisible dark matter and dark energy. Without dark matter pulling gas together early on, galaxies would never have assembled quickly enough to form stars like our Sun. We owe our existence to a substance we cannot even see. The cosmic background map acts like a precise time capsule that preserves the sound waves of the early universe. Before the light was freed, the hot, dense soup of particles experienced sound waves traveling through it, creating compression ripples just like sound moving through air. Scientists can analyze these ripples to read the universe's original fingerprint. These ancient sound waves pushed matter outward in concentric rings, creating a distinct pattern in the distribution of temperature variations. By analyzing the peak frequencies of these sound waves, cosmologists can determine fundamental characteristics of space, such as its age, expansion rate, and overall geometric shape. By measuring the size and spacing of those ripples, researchers proved mathematically that the geometry of space is amazingly flat. If you shine two parallel laser beams into deep space, they will travel for billions of light years and never cross or drift apart. This flat shape is a crucial requirement for understanding how the universe will behave in the far future. Do you think we will ever truly understand what dark matter and dark energy are? Drop your wildest theories in the comments section down below and leave a like on the video to support deep science discussions. Make sure to subscribe so you never miss our upcoming videos exploring the biggest mysteries of modern physics. Even though scientists have mapped this ancient light with extreme detail, the cosmic background picture has recently revealed new, unexpected mysteries that are keeping astrophysicists awake at night. Instead of answering every single question, our best maps have uncovered strange details that currently defy our standard laws of physics. One of the biggest modern puzzles is a massive feature known as the cosmic microwave background cold spot. In the southern hemisphere of the sky map, there is a giant region that is noticeably colder than the surrounding areas, by a far bigger margin than standard probability allows. This cold spot stretches across hundreds of millions of light years of space. Standard cosmological models predict that temperature fluctuations should be randomly distributed, making such a massive, deep cold patch extremely unlikely. It stands out on cosmic maps like a giant dark bruise across the sky. Some scientists believe it might be caused by an unimaginably giant supervoid, a region of space almost entirely empty of galaxies that drains energy from light passing through it. Other, more radical theories suggest it could be a footprint left behind by another universe bumping into ours in a vast multiverse. If the multiverse theory is correct, this cold spot could be the first physical evidence of another universe existing beyond our own cosmic bubble. It would mean our universe is not everything that exists, but merely one single bubble floating in an endless ocean of parallel realms. Another growing crisis in modern astronomy is called the Hubble tension. When scientists calculate how fast the universe is expanding today using the ancient cosmic light map, they get a value of roughly 67.4 kilometers per second per megaparsec. However, when astronomers measure the expansion rate directly by looking at nearby exploding stars and modern galaxies using the Hubble Space Telescope, they consistently get a faster speed of around 73 kilometers per second. This speed gap is far too large to be a simple measuring error on either side. Both measurement techniques have been checked and rechecked hundreds of times by independent teams around the globe. The gap persists regardless of how carefully astronomers analyze the data. This stubborn difference means that something major might be missing from our core understanding of space and physics. It hints that dark energy might be changing over time, or that a new undiscovered particle existed during the first few moments after the Big Bang. Some physicists believe we may need entirely new laws of physics to bridge the gap between the early universe and the universe we observe today. Right now, scientists across the world are building ground-based observatories in extreme locations like the high Atacama Desert in Chile and the frozen plains of the South Pole. These new telescopes are designed to measure the polarization, or alignment, of the ancient light particles to hunt for primordial gravitational waves. Polarization measures how light waves vibrate in specific directions as they travel through space. If violent gravitational waves rippled through space during the first fraction of a second, they would have left a distinct twisting pattern in the polarization of the cosmic background light. If these new experiments detect those ancient gravitational ripples, it will give us direct physical evidence of cosmic inflation, the hypothetical split-second moment when the universe expanded faster than light itself. It would allow us to peer back to a tiny fraction of a second after creation. Unlocking these polarization patterns could reveal the fundamental physics that operated at energy scales billions of times higher than anything we can produce in particle colliders on Earth. It would bridge the gap between quantum mechanics and general relativity, solving the ultimate physics puzzle. The cosmic microwave background is not just an abstract piece of scientific data sitting in a computer folder. It is the ultimate cosmic origin story that directly connects every single human being alive today to the very dawn of time. Every atom of iron in your blood, every carbon atom in your DNA, and every oxygen atom you breathe was forged inside stars that were seeded by those tiny temperature ripples. If those microscopic fluctuations in the first light had been slightly smaller, matter would never have clumped together, and stars would never have formed. If they had been slightly larger, everything would have collapsed directly into massive black holes. The precise temperature of that ancient light made human life possible. We are living creatures built from the debris of an expanding cosmos, possessing consciousness that allows us to look back at the light released at the beginning of time. Through science, our species has managed to decode a message written in light 13.8 billion years ago. When you look up at the night sky tonight, remember that space is not empty, dark, or dead. You are swimming inside a sea of ancient light that began its journey 13.8 billion years ago, traveled across unfathomable distances, and is reaching Earth at this very second. If you enjoyed this deep dive into the universe's oldest light, please subscribe to the channel right now and tap the notification bell so you never miss an upload. Drop a comment below answering this question. Do you think the cold spot is proof of a multiverse or just a giant empty void? Share this video with a friend or family member who loves space, science, and the mysteries of our cosmos. Thank you so much for watching, and we will see you in the next story.